Here we are, Pure Mathematics Year 2, Chapter 2, Functions and Graph, Question 10. We are given the function f of x as x over x squared minus 1 minus 1 over x plus 1. And they say to us, show that f of x can be written as 1 over x plus 1, no, x minus 1, x plus 1, x minus 1, x plus 1. Okay, so first things first, let's have a little look at this and see what we can do. That looks like the difference of two squares there, because x squared is a square number, minus 1, or 1 is a square number. So this can be written as x plus 1 and x minus 1 would be the factorization of that, which means this bottom one, to put it, this next fraction, to put it into the same units here, the same denominator, we can multiply it by 1 times x minus 1 on top, and also x plus 1, x minus 1 here. And so now as we put that together, we end up with x minus x plus 1 on the top, and the x minus 1, x plus 1, which of course is 1 over x minus 1, x plus 1. Okay, is f of x. Right then, find the range. Okay, so this is a interesting looking thing. If we have a minus 1 and a 1 on here, what are you going to have? We can't have x as 1 and x as minus 1 because it would give us a 0 on the bottom of here. So we end up with isotopes here. So this graph, this f of x, okay, looks something like, and it comes up and it scoots up there, and then it's going to do a sort of thing like that as it comes through, and then this one comes down here like this. Okay, now originally we were told in the question that f of x is defined, that's going to be curly brackets, as x as an element of the real, and also x is greater than 1. So that means we can basically cut this graph off down here, and we're only interested in the stuff that's bigger than 1, so ignore all of that. Okay, so now with that in mind, looking at what you've got, the range of f of x is going to be basically anything bigger than 0. So when f of x is greater than 0, because it just goes up that way. Okay, right then. Next bit they say for part C is solve g of fx 20. So they want to know what g of f of x is. It f of x equals 70, and solve. And I have also ignored the fact that they told us what g of x was, which was 2 over x, and that was when x was in the real and also x is greater than 0. Okay, so let's go and put f of x, which I'm going to use this version of it, into this, which is basically going to be 2 over the 1 over x plus 1, x minus 1, equal to 70. Well, That's a bit but not to worry. So what can we do with that? Let's multiply out with this whole thing here. So we're going to end up with 2 is equal to 70 over x plus 1, x minus 1. Now let's multiply this way so that we get x plus 1, x minus 1 is equal to, don't forget the 2, the 70, just to get it all out of there. And then we divide by the 2, which makes it 35. And I'm going to expand the brackets. We know the brackets expand to x squared minus 1 is equal to 35. So x squared is equal to 36. And so x is equal to the plus and the minus of 6. Now, g of x is only good for x greater than 0. F of x was only good for x greater than 1. So we will ignore the minus 6. So we will ignore minus 6, x equals 6 for a final answer. Now, rethinking that, I'm not going to ignore the minus 6. I think it's a perfectly valid answer, so I'm going to keep plus or minus 6 in there because the function of g of f of x equals 70 doesn't have the boundary conditions of it. It's only the function of g and the function of f that have it. So plus or minus stays.